talking about today's session now, we are going to build a model which will predict the credit limit of the user who is trying to create a new account on our platform. For that, we have two data sets, which is our users data and cards data. As this is a cloud platform, I would not recommend or I would not try to use our Giga file, which is the Giga chat for the complete analysis, which is our transactions file. But you can do that on your side as well if you want. It will highly cost you around 300 to 400 rupees, even if you try to do that, but not recommended because you just have to understand the tech, not the end-to-end project. It's fine if you are working with these two files. The idea would remain the same even if you try to implement it for a transactions file that we have, or you can do something that you can create a subfile for only a particular card brand and do the further analysis on that. Regardless of that, what we are going to do is we are going to set up this for the Sagemaker AI and we are going to write our code. So the number one thing that we are going to do is I'm going to copy paste the code over here. Reason I'm going to copy paste is because first, of course, I don't know how to write each line by myself. It will take a lot of time and not needed, honestly. Secondly, most of the code will be boilerplate code only. Okay. So over here, we are importing the Amazon SageMaker, then Boto3, which is to access the S3 bucket over here, then Pandas, NumPy. Inside SageMaker, I'm also trying to import the sklearn estimator, which is a sklearn library, then IO, import OS, then sklearn model selection, then sklearn processing, and then we are also going to import JSON. And in the end, we are initializing the SageMaker session and rule. Okay, so we are creating the SageMaker session over here. This is like creating an instance of SageMaker, which we created over here. And then we are going to assign the role. We are going to get the role. Basically, we are getting the execution role over here that my user is having. So it will just pass it on the execution role, which is in our case administrator access, so it can use anything. After that, we are setting up the bucket as this bucket over here. Okay guys, so this is a bucket which SageMaker will create. Initially, you will see that we have this random bucket over here, which is a part of my boiler code. But while you create this domain over here, right over here, let me just show you. Inside the admin configuration, you will have your domain. When you create your domain, the Amazon will automatically create a bucket for you, a S3 bucket. Now, what is S3 bucket? S3 bucket is like a database storage system that AWS provides. Why do we need it? Either we can store our data over here only, like we used to do in the projects that we make locally. But once you store your data over here, if I upload the data over here, it will be an elastic storage system, which will cost a lot more than the S3 bucket. Now, this is not your local computer, so make sure everything costs you something. Even the notebook that I've created right now will cost me something. So I have to delete the resources that I create. And using this elastic storage is not a good practice. So that is why we use AWS to store the data. And when we create the domain over here, it will automatically create two buckets, one for the Amazon SageMaker Studio, another one for the Amazon SageMaker AI. We are going to use the bucket for Amazon SageMaker AI. Now, how to know which bucket is for which purpose? It's pretty simple. All you need to do is you need to go back to the search over here and you need to type S3. Once you type S3, it will be something like this and you have to go to this S3 over here. Make sure it's S3 only. You have to go to this management console and you can see we have two buckets which are auto created over here. There is a bucket with some random name like this in the end, and there is a bucket without any random name. And the bucket of our interest will be something which is without this random name. Okay, so what I will do is I'll copy this name over here and you can see this bucket is currently empty. There is nothing inside it. And you can just copy the name over here. And then I will pass that name to this bucket name over here. Once I do that, it will get the name of our S3 bucket from where it will pick the data set which we are going to upload now before we do the further analysis. But before that, in the end, you can see we are also creating an instance to access the S3 bucket, which is my S3 client. A very simple step still needed. Once this is done, all you need to do is you need to run this code and pray to God that it works. Because if it works for the first time, it's a good sign. Regardless of that, what I'm going to do is I'm going to click Control Enter and I'm going to run this cell, and you can see it shows that star over here. And you can just ignore this over here, and you can see, yeah, it is running. Ignore this. Okay. Add a new cell, and yeah, this cell is executed. The reason it shows 3 over here is because we already executed print high for 2 times. That's why it is the third cell that we are trying to execute. After that, what we are going to do now is that we have set up the credentials for the S3 bucket. We have set up the session for the Sagemaker, and we have also initialized the role over here. Now we are going to get the I would call it as our files from the S3 bucket. So we have 2 files over here, which is our cards data and the users data.csv. So what we are going to do now is that we are going to upload these 2 files on cloud on our S3 bucket. So how we are going to do that is we are going to basically set up the path for that. And let me just show you the code only. Just wait a second. Okay, so yeah, I will just quickly put this over here. And you can see over here, it is taking data from this random directory, which is not our directory because we have not put the data over here. So where we are going to put our data, we are going to put our data on S3 bucket. So we'll set that path like this. Okay. So let me just change this to the S3 path. Just a quick second, I would say. Okay, so yeah, that looks good to me. Okay, so what I'll do is I will pass the path over here. So here we have this path, and instead of data, we are having users data.csv. And we also have cards data.csv. Okay, it will be users since the data frame name is user over here, and this will be cards data.csv. Cards data.csv. But till now, we are not having any folder like data in our S3 bucket. We don't even have these files over here. So we have to manually upload the files, and then only we can do this thing right over here. Let me just cut this. And I don't know why this shows an error. Regardless of that, what we are going to do is we are going to quickly come to this bucket right over here. And before we upload anything, we create a folder as data, because over here, we are storing this inside the data folder. So what I will do is I'll create a folder as data, keep everything as it is, just create the folder. Once the folder is created, go to that folder and upload the files, which is our cards data.csv and our users data.csv. Now, I assume that you already have installed those files from the data link, from the dataset link that I've given you. So first I will click on the cards data, and then I will add the another CSV file, which is my users data.csv. After you get both of these files, you just need to click on upload, and it will upload these 2 files over here. Coming back to the initial path, which is this one, you can see inside this initial bucket named as Sagemaker US East 2 and then some random number, I have this folder as data, and in data folder, I have 2 files as cards data.csv and users data.csv, which we are going to use for our analysis. After this step, let's take a 1-second break, and then we will look on this particular file right over here. Sorry guys, I just took a few seconds break. I just needed to drink some water and yeah. So now we are back. We have assigned the S3 bucket path to the data that we are going to have. And I hope you understand we are having this data folder, and then in that data folder, we are having these two CSV files, and we have created that data folder right over here in this bucket. You can see this is the data and this is our files. After that, what we need to do is we need to basically merge these two files. Since we have already discussed about this, in our cards data, the user's data ID is working as a foreign key. So we are going to merge these two files on the left join, and this will be basically giving us the card details along with the ID of the user who is using that card and all the details regarding user which was earlier stored in this users.csv file. So now basically we are having everything inside this merge DF, which will contain the unique ID as card ID because we have unique cards, which is around 6146. And then we are also going to have the details of the user who is going to have that particular card or who is assigned to that particular card. And yeah, that's it. Now, what we are going to do is we are going to drop some columns. Now, we don't need ID. We don't need client ID. We don't need card number. We don't need CSV. We don't need the address of the user. We don't need user ID. We don't need longitude, latitude. We don't need cards on dark web as well. So we are going to drop all these columns from the data frame that we have created as merged DF. Okay. And then we are going to rename the data frame as cleaned DF. Now, why we are trying to delete all these columns? And I hope you understand CVV is not of our use. Card number doesn't make any sense. It will not help us predict the credit limit of the user. Like card number? Seriously? Okay. And why card on dark web? Why are we also removing this? Because if you have watched the analysis of dataset, which I have put in this video as well, and if you have watched that in our other videos, cards on dark web is a column which is always no. So when you have a column which is constant, we will remove it because it will not help us to analyze anything or predict anything. Okay, so we'll just remove that. Once that is done, we will convert the columns into floating numbers. Since the credit limit is of type text, as we have a dollar sign before the credit limit. Let me just show it that to you over here if I can. So I don't know whether I can show you. No, I can just download it. I can't show you. Okay, it doesn't allow me to show it over here. So regardless of that, we have already discussed about that. So credit limit is of type float. I mean of type text. So we'll convert it to type float by basically just removing the dollar sign over here. It says some error, but don't worry, it will not give any error to us. Okay, so yeah, after that, or I can put a F over here. Oh, I won't. Just don't worry about it. It won't give you an error. Okay, so after that, we have the per capita income as well, which we will convert into a type of float. We will basically remove the dollar sign and convert it into a floating a variable type from the text variable type. Okay, so we'll do it for these four numerical columns over here. And after doing that, we are going to basically first put that in a list, which is money calls. And then we are going to iterate through this money calls using this call as a iterator. And I'm going to pass this inside it over here. And I'm going to replace each instance, or I will say each value with the by removing the dollar sign and then converting it to as type.float. So it's a pretty basic regular expression conversion, which you can do it on your side as well. After that, we'll also make sure that we convert the expiry year into date time format and also the account open year into date time format. And since we are not going to use this, we'll remove this as well. Though we have changed this because I want to show you how to convert a text into a date time format, which is like you're going to use the toDateTime function, and in which you will pass your expiry and you will pass the format, which is month year or year month or anything like that. Okay, but since expiry year and account opening date is also not a factor to predict the credit limit, we will remove that from the analysis. After that, we'll create some feature engineering. That means we are going to create some features over here, which is like our debt to income ratio. Now, see guys, suppose you are having a debt of 1 crore rupees and your yearly income is just 5,000 or 5 lakh rupees. So you are under a huge debt. But if a person is having an income of 50,000 crores and he is taking a loan of 1 crore, so for him that loan is almost like negligible. So just talking about the debt in itself would not be enough. So what we are going to do is we are going to talk about the ratio of total debt to the yearly income so that we can get a better idea of at what level the person is standing. Okay. So then we have the account age to know the age of the account, and then we have the income per card, which is like yearly income divided by the number of cards that the user is having. So suppose a user is basically trying having a good yearly income, but he's trying to get a lot of cards. In that case, he might default in future. So we want to make sure what is his income depending on the number of cards that the user is having. Okay, so after doing that, we'll get averaged income on the basis of number of cards that the user is having. So that income will be like income per card. Okay, and then we have this categorical columns over here. We have 4 categorical columns. We have card brand. In total, we have 4 card brand as MasterCard, Visa, Amex, and Discover. Then we have card type as credit, debit, prepaid. We have hash chip, whether a card is having a chip or not. Then we have gender as male and female. After that, we are basically get dummies, and we are just trying to get these card details over here, and we are storing that. We are trying to encode the variables, categorical variables. So instead of having the categorical variable brand, suppose card brand as Visa, MasterCard for Amex and Discover, now we will have the names as 0, 1, 2, 3, and 4. Okay, so machine learning doesn't understand words, it understands numbers. So we are converting everything into numbers. After that, we'll put the features in this column right over here. And we will not put the credit limit in the features because it is our variable of interest. So we'll put that in the Y, whereas all other will be in the X. So now what we are going to do is we are going to simply just use this line. It is a very standard line. I hope you understand. If not, let me tell you. What we are trying to do is we have got the features in X and the, I would say the output which we want, which is our credit limit in the Y, something that we want to predict. So the features are our predictors and the output is our independent feature which we want to predict. Okay, so X train will be our training data, X test will be our testing data, Y train will be our training label, whereas Y test will be our testing label. So we are going to use this train test split function provided by sklearn, and in that also you can see over here. Oh, I forgot I can zoom. Sorry, guys. So in that also we are passing the test size as 20. That means I only want my 20% of the total data to be used as test data, whereas remaining 80% of the data will be given to the training part. Why I have put this random state as 42? Because I want every time that this split is always the same. So suppose if you are also running this code on your side, you will also get the same accuracy as I am getting because I am putting this random state as 42. So the data will be splitted in the same way as I am trying to split. Okay. So if I change this to 24, it will be 24. It's just a random number. There is no such significance of what number do you choose. So regardless of that, what now we can do is we can run this code over here. Make sure your data is stored correctly on the S3 bucket and your name of the S3 bucket is correctly assigned. See over here, I've put this space. This can be error. So make sure you check everything. And I have to run the above cell again because of this small issue. So I'll press Control Enter and it will run the cell. After that, I will come down and I will run this cell as well. It will take some time, it will load, and you can see over here, this cell is executed as well. So yeah, now we have transformed the data. We have used a standard scaler as well in order to basically transform the data that we have, which is X and Y. Now, what is standard scaler? What the standard scaler is trying to do, it will try to basically put all the values between the range of -1 and 1. Why do we need to do that? Suppose there is something as credit limit, which is like in the ranges of 10,000 to 50,000, and there is yearly income, which is in the range of 30,000 to 5 lakh. And then there is a age, which is just like from 0 to 100. So because of this uncompatible ranges, we are trying to put everything between -1 and 1 so that it is easier for us to analyze and it will be a good option. So yeah, that is what it is. Our standard scalar, we are first creating an instance and then we are using it to make our transformation, make our features, which is our X train and X test, and that is it. So yeah, what I will do now is I will simply just run this code, which I've already done. And after that, let me just show what is the next step, because again, I have already make sure that I have this code pre-installed in my computer so that I don't get any errors while I work with you guys. Okay, so now what we are going to do is, since we got our updated files over here, as you can see in the third code cell, we have to save the CSV file without headers. Okay, so without header means we are not gonna get the header, which is like credit limit or the feature headers that we have. We are going to remove all that. So for the part over here, we are going to put this in the train df, and this will be the test df, which will contain the scaled features that we created right over here. Okay, and after that we are going to put this in the buffer. That is just a step, guys, don't worry about it. And then we are going to convert this to a CSV, and we are going to store this CSV, as you can see, s3.client, which we created initially over here, which will help us to access the S3 bucket in this notebook. Okay, so using this S3 client over here, we are trying to put this train.csv and the test.csv. Okay, and once this is done, both of these files are uploaded in this new folder, which is train and test. We will basically also set up the path over here as this, and we will print that path to our end user. And once the job is done, we'll save this file name as scalar file. And yeah, that is it, what we are gonna do. So now what I will do is I will quickly just wait, give me a second. Yeah. So what I will do is I'll quickly just run this code over here. And in this code, basically, we are just saving the files in our S3 bucket, our cleaned data to our S3 bucket. So once I run this, you can see a star over here. And yeah, the training data is uploaded to S3 and then the S3 bucket name that we have created. And then the credit limit prediction is like the project that we are working on. In that, we have the folder as train, and in that also, we have the data in the as train.csv, and in the test, we have the data as test.csv. Let's look at that. Let's go back to the buckets over here. We are going to this bucket. Make sure you don't click over here. This is for Amazon Sagemaker Studio, whereas this one is for our Jupyter Notebook. So we have this credit limit prediction over here. We have the scalar, we have the test, and we have the train. So we'll go back to the train, test, and you can see the test data over here, test.csv. We can see the train data over here as train.csv. That is it. That's what we needed to do. Now we will start with our training job, guys. So either you can create your train.py as a separate file, or you can use this notebook to create that file. So let me just run this code over here. Here I'm basically trying to create a new file as train.py, and this is the code that file will contain. So before I show you the code, let me just quickly run this file over here, because it is just creating a new file named as train.py, and then we will see the code inside train.py. So if I run this over here, and you can see over here, just a second, I don't know why it is taking time. Yeah, you can see over here, it is my train.py file, which is having importing this arc parse and this OS and a lot of other libraries over here. Then I have this model fn, which is going to basically load the training model. So what happens is, guys, in our Sagemaker, we have to load the model. So once your model is done, we have to load that model. We have to store that model. Okay. So in order to do that, we are going to attach this path over here, which is my joblib.load and os.path.join and model directory, in which I will store this path with this name over here. And in the end, I can return this model if we want to use this model for the creation of endpoints. Okay. So basically, in the input function, we are passing a JSON input, which will give us the output as a instance. Okay, so basically, input function is this is a boiler code. You don't have to worry about it. In almost every kind of a machine learning model, you will use same kind of boiler codes. So what we are trying to do is we are trying to pass on the test data, and then this input function will basically convert that data into a request content type, and this predict function will be basically model.predict. And yeah, you know what's the game? It is going to predict the output for us, which is in our case credit limit. So these are the boiler functions, or I would say boiler code template, which you are going to use in almost all of your projects. So it is not something which is like too hard to understand. This is basically a definition of the function which is written over here. Parse the input data for prediction, load the training model from the model directory. So we have our model directory from which we will load this model. And then, yeah, this is our main function. Going in the main function, we are first going to create an instance for this arg parser. And then we are going to add this model directory as the argument inside this environment of our Sagemaker. So now this is also a boiler code. Basically, we are creating this model directory where we will store our model and also the training data which we are going to use to train our model. Okay, so this is my Sagemaker channel path channel train. Okay, so this is basically a parser that we are trying to use, and we are storing these two things. In the end, we are getting this args from the parser, which is like this arguments which we assigned over here. Now, with the reason there is a comma and the underscore over here is because this parser dot parse known argument will give us two values, and we only care about args over here. So for the other, we'll just keep it as underscore, and we just don't want it. Okay. After that, we'll load the training files from this args.train. So as you can see, I'm assigning this as train. So inside the args, I will get from this args, I will get the training data. And for the training data, I will check whether there is any other args.file. So for f in os.list directory inside args.train. So right now we are only having one training file inside our args over here, but maybe there can be more than one training file. So for that, we have to basically use a for loop to check for each file which is ending with .csv, and we have to load that file in this training files. Similarly, for the training data, what we are going to do is we are going to concatenate. Basically, we are just trying to read each of the CSV file, and then we are trying to concatenate it, and basically we are just converting it to a data frame. In the end, we have this X train, and we are going to train data. In the end, we also have the Y train. So we are going to get the labels of that. Okay. And this is our model, which is going to be the random forest regressor. In my case over here, we have n estimators set to 200. We have the max depth set to none. We have min sample split as 2. We have the max feature as square root. We have the random state as 42. Then we are going to fit this model to this training data that we have. And then in the end, we are going to dump this model to this args.model directory, which we created over here into our Sagemaker. I hope you understand what we are trying to do. And all of this is done inside this train.py. Once I come back to the notebook which we created, this is what the script of our train.py looks like, and that's how we created it using our notebook. So you can create a separate train.py file all by yourself and put this, or you can use this notebook to create a file for you and put everything inside. Now, I don't want you to feel that you are not doing a lot of things. You might be not able to understand what is going on in this code, because you can use a basic boilerplate, and I've used the same. It is not hard. You can read the code. We have this 3 function. This will load the model. This will take the input and convert it into a parse the input data for a prediction. And after parsing, we are passing that input data, which we are returning right over here for predicting the output labels. Okay. So yeah, that is what it is. Now comes the important part. We have to train the model which we created, which is our random forest model. So for that, what we are going to do is I will be just quickly copy pasting this for you guys. And this is where the important things come. Entry point will be my training.py. Role will be the role which I have got from here, which will be the role of the person using this. So for the training, it will ask for the role. Suppose you are one who created all of this, and you are not having that policy of um, basically training the models. As I've told you initially, we have given the policy as administrator access, so we can do everything. But if you don't have, then you will be not able to train the model on SageMaker. So since we have already given it administrator access, we can use that. Then over here, we have instance type as ML M5 large. Now guys, as we discussed before also, this instance will cost you money. Initially, this notebook was set up on, let me just show you. Click on this application. I hope you have the screen on here. It is ML T3 medium, but now this is ML M5 large. So this will cost you more. How much? You can check it on your side. The way to do that is pretty simple. All you need to do is you need to go on AWS pricing for training jobs on SageMaker AI. So now, once you come over here, you have to click on this machine learning services on this particular Amazon SageMaker AI. You need to come down and you need to click on this training jobs over here. Training. Okay. In that, which model are we using? We are using ML M5 large. Right now, it is not going to cost you something because it is not running. Once you click run, it will cost you the money. Okay, guys. So let me just quickly show you what ML M5 large looks like. So yeah, this is my ML M5 large, and for every hour, it will just cost me $0.115, which is a very less amount, but still it is better than our initial instance that we used, which was pretty cheaper. But for training, it will take a lot of time, so we are going to use this. Then we have the Python version, and then we are passing the SageMaker session, which we created right over here, so that it knows that SageMaker is going to execute this training job, because this training job will be shown. Let me just go back to the SageMaker. Make sure to click on SageMaker AI instead of SageMaker. So over here, we will go to the training jobs in order to see the existing training jobs. So right now, it will load. Right now, you can see inside the training over here, we have, it will always take time to load. So inside the training, you can see over here, we have training jobs. Initially, I have no such training job which is currently executed. That's why it shows completed for the 4 which I created before and failed for the 1 which I created before. But now as soon as I press enter, and make sure in the end, it will fit the training data from the S3 training path. And this is my S3 training path, which you can see over here. Okay. So S3 training path. I hope you understand. Look once again, this is the S3 training part. Okay. This is the S3 training part. Okay. So now we will just simply run this. This will take time, guys. So have some patience. It might take from 5 to 6 minutes for this code to get executed. So as soon as I press Ctrl plus enter, see, it has started the execution. If I come back to the Amazon SageMaker AI, in the training jobs, if I try to reload this over here, you can see that it will show you a running training job. Okay. So job status will be running. Wait for some time. It says in progress, and the job secondary status, it's starting. So this is our current training job. Coming back over here, it says starting the job, and it will give the, it is basically the logging, which we are going to see in the future. And you can also watch Vikas Das MLOps playlist to understand what is logging. So this is basically logging over here. So he has explained logging in a pretty basic way, and I would highly recommend you to watch his playlist for this. So yeah, it is saying that preparing the instance for the training. So it is basically preparing our ML M5 large instance for us, and it will do all the steps. It will take some time. So once it is up and running, what we are going to do, we are going to see the training model that we got, and then we will create the endpoints which we will use to basically see how the predictor works for the data. Okay. So yeah, as you can see over here, once you try to basically run the code, after a couple of minutes, it will be executed and you will see the status as complete over here. So it took around 3 minutes for us to run this code. So according to that, you will be charged for using this particular instance, which is ML M5 large. Okay. Regardless of that, you can see the logs over here. It basically downloaded the training image download completed, uploading generated training model, and then in the end, training job completed, training seconds 114, billing seconds 114. It's pretty simple. Now after that, since we created our training model, we also want to deploy the endpoints for this particular model over here. So it's a very simple step. We just have to create a predictor and then sklearn estimator.deploy, and that we are going to deploy this on the one instance, which is our ML M5 large. And in the end, we are going to name this endpoint as credit limit endpoint. As soon as I run this code, it will take some time. And then you can see over here, let me just show you that. Wait for a second. It will take some time. Meanwhile, we can come over here and we can go to this inference right over here. In that, you have to click on endpoints. Right now, we currently have this endpoint which is creating, not created. Okay. So this is our endpoint. Coming back over here, guys, over here, you will see that after some time, not right now, just wait, you will see a underscore. And that underscore, see over here, this underscore shows that currently the endpoint is being created. Once you get the exclamation mark, that exclamatory mark, that means your endpoint is deployed. And then you can test that endpoint. This can take up to 5 to 6 minutes. So you have to again have some patience for the model to be deployed on the Amazon Sagemaker. And once it is deployed, you can use it. Right now, the status is creating. Over here also, you can see we have 2 underscores. After some time, once you get the exclamation, it will be up and running. Make sure to not interfere or change anything in this. Just keep it as it is and make sure it is running correctly. Okay. So after it will be executed, this cell, then we will talk about the further analysis. Okay guys, so you can see over here, once our endpoints are being deployed, it will show exclamation sign just like this. And I hope you got the same. If you got some error, make sure to comment down your errors below. We'll try to figure out how to solve those errors. Regardless of that, for most of you guys, you will see something like this. After that, what you need to do is you just need to go back over here and you can see your endpoint is in service. Okay. So under the inference right over here, you can see the endpoints and it is, the status is running. Okay. So after that, coming back to the credit limit notebook over here, what I want to do is I want to predict the credit limit. Since our model is created, since our model is deployed, how to check for the credit limit now. So what we're going to do is we're going to basically test the endpoints and then we are going to see how the model works. So we have the details right over here as it is. You can check this out on your side as well. So these are all the details that we have. This is a sample example that I'm going to pass. Also, we will be looking at the model's accuracy, mean squared error, mean absolute error, and the R squared score, which will help us analyze how well our model performed. Okay. Over here, we are trying to basically serialize the data into a JSON serializer because we are passing the data as JSON instead of CSV. Basic steps, nothing much. We are preparing the data set and then we are basically, I don't know what was that error. Let me run again. Okay, so yeah, we are getting these things over here. Oh, maybe that would throw an error to us. Maybe that would. Regardless of that, let me just quickly run this code right over here. And as expected, we are getting this error because these things are not defined, guys. We have not defined those things yet. We have not trained the model or to basically tested it. So we have not yet tested it. So I'm going to remove this. This evaluation can be also done over here. We are not going to look about evaluation since we have already deployed the model, and I already know the evaluation, which is like around 0.68 for the R squared, which is like it predicts the 68% of the data correctly. And so yeah, with that note, we'll just run this over here, and we are passing these features in order to predict the credit limit for the person. So 0 means he's a male and he has a chip. Credit type is like he has a credit. The card is of type credit. Card is of type debit, which is 0. And then we have card per brand and the other variables right over here. So card brand is not Visa. It is basically, let me just quickly go through. It is MasterCard. Okay. Card brand is Visa. Sorry. So yeah, after passing all these variables over here, I'm going to just press Control and Enter. These are all my, I would say, all my features which I'm passing, and in the end, I'm getting the credit limit as 15,475, which is around 15,500. So suppose you are a bank and you want to assign a credit limit to a user. Every time you're not going to check everything by your side. You have to make a system to do so. So this is a very small project, but imagine guys, you're working in a bank and you have all these data sets. You can make a fraud detection system. You can make a control system with a lot of other variables by adding those variables to our analysis. Right now, we had very basic variables like yearly income, credit limit, or I would say yearly income, credit score, and then per capita income, things like that. But in the future, when you are going to work with a larger organization, they might have a lot of data and you will be having an amazing team to work with. So just guess, you are going to work on a live project which will be somewhat like this only, where your end goal was to predict the credit limit for a credit card that you are going to assign. To be on the safe side, yeah, that's how you do it. So that was it for today's video. Before you end this video, I also want to tell you guys that it is everything that you need to do for this video. This was it. But still, the last and the most important part is still remaining. Because if you close this window right now as it is, after 1 month, you will probably speak bad words in my comment section that I got some bill on my AWS cloud. So make sure to delete this endpoint which you have created. So what I will do is I will go back to this notebook over here, and I will just simply do one line over here, which is delete the endpoint, and that is it. Before that, let me try to see what is the effect of using the gender as female. Okay, right now it is as male. So what I'll do is I'll convert it to female. Okay, I hope it is not something controversial. Let's just test that over here. And it is again the same, I guess. Oh, it has to be 1. Okay, so yeah, let me just run this over here. And now it is almost the same. So yeah, I guess that is not an issue. Let me change the number of cards to 1 only and then try to analyze it. This time the credit limit is somewhat different. Okay, so maybe current age can be a factor. Let's change the current age to let's say 22, then try to analyze it. Now the credit limit has reduced. Okay, so like that, you can try it on your side. I will put the code in the description. You can download the whole file, which is my IPYNB, as a IPYNB file, and then you can follow the step which we did on the cloud platform. I'll provide the GitHub link in the description from where you can get it. Okay. Regardless of that, we have to delete the endpoint. So for that, we will do predictor.delete endpoint, and we'll just press Control and Enter, and it will delete the endpoint. Wait for some time. Let it delete the endpoint before you click on this. Okay. So wait for some time. Let me wait as well. And coming back to this inference over here, going back to the endpoints, you can see we don't have any endpoints now. That means the endpoint was deleting endpoint with the name credit limit endpoint. So now you can safely close this, but remain here only, because guys, even if you are not using this notebook right now, also your kernel is active and this notebook is active. So make sure you delete this notebook. But before that, I'm going to save this notebook as it is. And yeah, it is done. It is saved perfectly. I'm going to save this again. And then what I'm going to do is I'm going to download this notebook over here. So I'm going to go to this, just a second. I'm going to click over here and I'm going to download this so that I can put it on my GitHub. And yeah, after doing that, what I'm going to do is I'm going to delete this notebook. So I will just click on this notebook and press delete. Make sure you delete everything, which is our scalar job.lib as well as our ipynb, our train.py. After that, you can also go to this right over here and you can see there is no current service activated. You can safely exit out of this. But over here also, you can see once you go back to your Jupyter lab over here, the application is still running, which is not a good sign. You have to stop it. So click on the stop, make sure it is stopped and wait for some time until it is stopped. Again, you can click on run and use it. Otherwise, you can create a new Jupyter lab space and use that. So for now, I'm going to click on this and I'm going to delete this space right over here. Click on this 3 buttons and click on the delete. I confirm I want to delete this space. Okay. So yeah, click on delete and it will be deleted automatically. So now you can safely exit this as well. Now do one more thing, go back to your domains over here and make sure that you delete the domain over here as well. But before you delete the domain, we have to delete the user which is inside this domain right over here. So we'll go back to the users over here and we're going to click on this user and we are going to delete this particular user. So we're going to click on this delete button right over here. We're going to click on yes, delete, and then we are going to type delete and delete the current user inside the domain. Once we are done with that, we'll go to domain settings over here and you can see there is an option to delete the domain right over here. You won't see this option unless you delete your user inside the domain. Click on this domain over here. Yes, delete my domain, and then again do the same steps. It will take some time. Come back to the domains right over here and you can see the domain is basically deleted. Go back to the inference and check the endpoints over here and you can see the endpoint is also deleted. Inside our models, as I've told you, SK Sagemaker will create its own model directory. Over here, this was the model which we created today at 5:51 on 15th of April 2025. So make sure that we try to delete this as well. Although it is fine if you don't delete it, it will not take a lot of space. Still, a great advice to delete your models after you use it. So click on the models and delete if you want. Regardless of that, coming back to the training job, here we can see the training job which we done. It will show you that it is completed. We don't have to delete it. If you want, you can just come over here and yeah, it doesn't matter if you delete it or not. It will not cost you anything. Coming back to the domains over here, you can see we have no active domain. Coming back to the endpoints over here, we have no active endpoints. And yeah, that's how you safely make sure that after your projects, it will not cost you anything. But till now also, we have some other things in our S3 bucket. So going back to our S3 bucket over here, I can delete the data as well. So as I've told you, while you create a domain, S3 bucket will, the Sagemaker will automatically create 2 S3 bucket, one for the studio and one for the Sagemaker itself. When I click on the Sagemaker, it will have the details over here. Inside the Sagemaker, you can see we have the output as our model, which is our machine learning model. You can download it if you want, or you can just delete it. So I will click on it over here. I will delete it. I have to type permanently delete. So I'll just copy it from here and then I will type it and I will delete it. Like that, you have to individually delete everything. And that's how you make sure that it will not cost you anything in the end. And yeah, now I click on these 3 at a time. And if I try to, let's say, delete it, it will, just a second. So it will successfully delete that as well. Coming out of it, now I will delete my credit limit predictor as well as data folder as well. I will go to delete and then I will pass permanently delete to delete these as well. Once this is deleted, I am basically having an empty file. So if I click on this empty bucket, I can now delete this whole bucket. Make sure you have to pass the complete name of the bucket. Just copy it from here and paste it over here, and tada, you have deleted it. Once it is deleted, we have this other S3 bucket as well, which is already empty. So you just need to copy the name of this bucket and press delete button, which I will do right over here. Coming back to the buckets, click over here, press delete, and then delete this bucket by passing the name of it. And yeah, you are done with that. So now S3 bucket, we don't have any bucket. And for the Sagemaker AI, make sure you don't have any active domain and you don't have any active endpoints. That is it for this video, guys. I hope you really enjoyed everything we've done in this video. We tried to explore Amazon Sagemaker AI, which was really amazing. We can do a lot more in this. We can use Lambda function, which is the scope for the future. We can create APIs, which we can then use in our applications, but this is all for the future episodes. For now, that was it for the general overview of this beautiful platform provided by Amazon Web Services. So yeah, that is it for this video. Have a nice, beautiful, and a healthier day. And yeah, bye-bye.